Hi grade 11s and welcome to this video. In this video we will be working on the Mathematics Paper 1 for June 2024 and this is specifically from KZN. Question 1 says 1.1 solve for x and we're given this equation to solve for x. Now do you notice that one hand side is already equal to 0 and this has been factorized already, okay, because we can see the brackets. So something multiplied by another thing gives us 0. The only way this is possible is if the first was equal to 0 or the second was equal to 0. So you multiplied it and then it gives you 0 because 0 times anything stays 0. So we'll simply say x is either equal to 0 or 1 minus 2x is equal to 0 and then solve for x by taking negative 2x over, so 1 equals positive 2x, and divide both hand sides of the equation by 2. Therefore, x is equal to, and we have 1 over 2. And that is our answer. Moving on to the next question. Question 1.2, as you can see, this is not the case where we have to use the quadratic formula. They have given that in question 1.1.3. So let's go. Okay, so we need to factorize this. And so to factorize it, we open up two brackets. There are two ways that you can factorize it, but just use any way that you're comfortable with. So I'm going to deal with this using the cross method. So with the cross method, we look at the factors of the first term. So that's 2x squared, meaning 2x multiplied by x gives us 2x squared. And then we need the factors of the last term, which is 3 and 1. But here's the thing. The middle is negative, right? And this is positive. So you must have said positive 3 times positive 1 to get this positive 3, or negative 3 times negative 1. Now, in this case, because the middle is negative, we clearly said negative times negative. And so now when we cross multiply and add our product, we should get negative 5x in the middle. So when you say 2x times negative 1, we get negative 2x. And then x times negative 3, we get negative 3x. And that indeed does give us negative 5x. So we know these are our factors. So our factors are 2x minus 3 and x minus 1. Okay, so like the previous question, you can see something times something gives you 0. Okay, so the only way this is possible, the only way this equation will be true, okay, left is equal to the right, is if 2x minus 3 is equal to 0 or x minus 1 equals 0. And then 2x is equal to, we transpose the negative 3 to get positive 3. Divide both hand sides of the equation by 2. Therefore, x is equal to 3 over 2. And then here, x is equal to, just transpose the negative 1. So positive 1. And these are our solutions. Moving on to the next question. Question 1.1.3, they say we need to solve for x in this equation correct to two decimal places. Okay, so here we clearly have to use the quadratic formula. So one hand side is not equal to 0. You can see that this has to be expanded further. So multiply in, we get 3x squared, and then distribute. That gives us negative 5x. And you can just transpose the 7. So minus 7 equals 0. Okay, so now this is in the standard form of a quadratic equation. So ax squared plus bx plus c equals 0. And so we need our quadratic formula, which is x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. Okay, so x is equal to, and we say negative, and b is negative 5, and plus minus the square root of negative 5 all squared minus 4 times a, which is 3, times c, which is negative 7, and then finally all over 2a, which is 3. Okay, starting with the plus, x is equal to 2 point, and then that's going to be 5, 7, okay, rounded off to two decimal places, or x is equal to, and we change that to a minus, and we get negative 0.91. And that is our answer. Moving on to the next question. The next question is an inequality, and we need to solve for x in this inequality. But do you see how these are factorized? Yes, but one hand side is not equal to 0. So clearly we need to transpose this, and we still need to distribute here. So we will multiply in, and 1 times x gives us x. 1 times positive 3 is just positive 3. And then negative x times x is negative x squared. And negative x times positive 3 is negative 3x. and then this negative 5 will come over to become positive 5, now is less than or equal to 0. Okay, so we have negative x squared, and then if you say x minus 3x, that gives you negative 2x, and then positive 3 plus 5 is positive 8 is less than or equal to 0. Now, we would have been able to work with this, but the thing is we need to find our factors. So we need to ensure that this is positive. Okay, so the coefficient of x squared must be positive. And so we can make it positive by dividing both hand sides by negative 1. But if you multiply or divide by a negative number with inequalities, the sign is going to change. So this becomes positive x squared plus 2x minus 8 is now greater than or equal to 0. Okay, and now we can go ahead and factorize. So open up two brackets, is greater than or equal to 0. And factors of x squared, so that's x times x gives us x squared. Factors of negative 8, that can give us 2 in the middle. So first, it is negative, meaning one should be negative, one should be positive. So I know that 4 and 2 can give us 8 when multiplied. But then if we make the 2 negative, then 4 minus 2 is positive 2. So our factors are positive 4 and negative 2. Okay, so now let's get our critical values. We get our critical values by equating this to 0. So if you did that, x would simply be equal to negative 4, or x would be equal to positive 2. Okay, and now we can solve for the inequality. To solve for this inequality, you are just going to focus on this part. See, once you simplified it, okay, and one hand side is equal to 0, we can just focus on that. So you see that in this quadratic expression on this side, we have the coefficient of x squared being positive. So if you had to draw this as a graph, you would get a concave up parabola or smiley face parabola, and we're going to put down our x-axis. And so we're going to put down these critical values here. They're really just our x-intercepts. Okay, so this is negative 4 and positive 2. And here's how we solve for this. So with this, let's start with a negative 4 and positive 2. You see, if you take negative 4 and positive 2, and you substitute them into this equation, you will get a 0. We're trying to solve for this inequality, meaning find the values of x for which, when you substitute x values into this, the entire expression ends up being greater than or equal to 0. So we know that negative 4 and 2 definitely will give us 0, okay, if you substitute negative 4 or if you substitute 2. But now, which values of x will ensure that this expression is greater than 0? So for values that are greater than 0, we are referring to the outputs, because when you substitute x values in here, you will get a corresponding y value, the outputs. So those are y values, meaning they lie on the y-axis. Where we're looking for y values that are greater than 0, these are y values that are positive, okay? Numbers greater than 0 are positive numbers. And so positive numbers would lie here, meaning all the parts on this graph that have y values greater than 0 would lie above the x-axis. And then if it has y values less than 0, if we're looking for y values less than 0, that would be below the x-axis. So we know here they're asking for values that are greater than 0. Of course, equal to 0 as well, but greater. So meaning we're going to look for places or parts of the graph that lie above the x-axis. So if we highlighted those, that would be all through here and all through here. And now let's line this down to the x-axis so we can understand exactly what the x values are. So compared to negative 4, these are values that are clearly moving to the left-hand side of negative 4. So these are values that are less than or equal to negative 4. Or, and then compare them to 2. So if you line this down, it's moving to the right-hand side of 2. So these are values that are greater than or equal to 2. Okay, and that would be our answer. X is less than or equal to negative 4, or x is greater than or equal to 2. And that is our answer. Moving on to the next question. Question 1.1.5, we have an algebraic equation with fractions. Okay, so to solve for x in this equation, you need to focus on factorizing, because if you can factorize these, you can make them look simpler, and then you can find things they cancel with. So do you see that with this, we can actually factorize that further? So the numerator is still x squared plus 7, but then the denominator will factorize to open up two brackets, and what times what gives you x squared? That's x multiplied by x. And then what times what gives you negative 3, but will give you negative 2 in the middle. So this is negative, meaning 1 is negative, 1 is positive, and 3 is a prime number, so it's just 3 and 1. But if you make the bigger factor 3 negative and the 1 positive, we know that negative 3 plus 1 is negative 2. Okay, so it's minus 3 and plus 1, and those are our factors. Okay, and then we have 2 over x plus 1 and is equal to negative 1 over x minus 3. Okay, so all through, do you see how we are adding? And then, of course, here we have this. To add fractions or subtract fractions, you need to ensure that your denominators are the same. Now, the denominators here, they're not the same, but they're very similar. So with the denominator here, what we can do is, you see this denominator, okay, we can get this denominator to look like that, because this one has the x plus 1, but it just doesn't have the x minus 3. So if you multiply this fraction, okay, numerator and denominator by x minus 3, the denominators will all be the same. So I'm going to write them under the same denominator first. And so this one, nothing really happens because it already has this denominator. But with this one, we have, you see, in the numerator and denominator, we multiply by x minus 3. So it multiplies here and here. When it multiplies here, your denominator just ends up looking like this. When it multiplies here, what's going to happen is we're going to distribute. So that's going to be positive 2x and then negative 6. And then we're done with that. Same thing on this side. We want to ensure that the denominators are the same. So what would we do to this denominator to get it to look like that? Well, it already has the x minus 3. So you can just multiply that denominator by x plus 1. Okay, and when you do that, the denominators end up looking like that. And then it also multiplies to the numerator, so we're going to distribute there. And so that is negative x and then negative 1. Okay, and then we have x minus 3 and x plus 1. And once the denominators are the same, you can drop them. And the reason you're able to drop them is because we're just really going to multiply both hand sides by those denominators to get rid of them. So it's like saying multiply by x minus 3 times x plus 1. On this side, so it cancels with that denominator. And same thing here, if you multiply it, it will cancel with that denominator. And so all we are left with in the numerator, and this is just all that is left, is x squared and then plus 2x. And then we can just say 7 minus 6 is plus 1 is equal to negative x minus 1. And all we are doing is solving for x in this equation. Okay, so this is already a trinomial. Might as well just bring everything over. So we have x squared, and this is positive 2x. That becomes a plus x. So we have positive 3x. And then this is plus 1. That becomes a plus 1. Becomes plus 2 is equal to 0. And then we can factorize. So factorize this is equal to 0. X times x gives us x squared. Then we need factors of 2 that can give us 3. So 2 is just 2 and 1. And they're both positive. So plus 2 and plus 1. Finally, this means that, as you can see, one hand side is equal to 0. It means x is equal to negative 2 or x is equal to negative 1. And so these are our solutions. But then we still need to test. Okay, so these are our answers, but we still need to look at this. You see, initially this was a fraction. So there are some values that would have made this undefined, and we could have discussed this initially, but you're still going to have to consider this. So you see that you can actually just take it from when it was factorized because it will be easier here. So in this case, do you see that you had x minus 3? If x was equal to 3, then you'd have had 3 minus 3, which is 0. 0 times anything stays 0. So the denominator here would have been 0, making this undefined. And so we know that x should not be equal to 3. That's the first thing it shouldn't be. And then here's another factor we have. We have x plus 1. So if x is equal to negative 1, so negative 1 plus 1 is 0. So in that case, it will also make the 0, and then it's going to be undefined. So x should also not be equal to negative 1. And those are the only factors we had. Okay, 3. Okay, it shouldn't be 3 and it shouldn't be negative 1. Okay, no other denominator is really going to be a problem. So these are two things we should ensure we do not have. So let's just see. You see that in our answers, here we got where x is equal to negative 1. We cannot accept that. So it means that x is only equal to negative 2, and that is our answer. Moving on to the next question. Question 1.2 says given, and we have been given an equation with a surd, we need to solve for x. So x minus 3 equals 2 root x. The rule with equations with surds is you need to isolate the surd. But you see in this case that the surd has already been isolated. So we can simply move on to the next step, which is to get rid of that surd. It's a square root. The only way to get rid of it is to square. But what you do on the one side, you must do on the other side. So this gets squared, and we can start by squaring the first term. It becomes x squared. Square the last term, it becomes positive 9. And then first term times second term, that gives us negative 3x. And then times by 2, which gives us negative 6x. And this is equal to, you see these two are together because they're being multiplied. So the 2 gets squared and becomes 4. This root x gets squared and that radical breaks open. And so we're left with x. Okay, so this is what we have. We can just take that 4x over, so x squared minus 6x, and this becomes a minus 4x, which together give us a negative 10x, and then plus 9 is equal to 0. Okay, so let's factorize. Open up two brackets, equate to 0, x multiplied by x gives us x squared, and now we need factors of positive 9 that can give us a negative 10 when added. So it's a positive 9. You can get positive by saying positive times positive, or negative times negative. Clearly, it's negative times negative in this case. If not, we wouldn't have a negative middle term. So factors of 9 that can give us 10. That'll be 9 and 1. See, negative 9 minus 1 is negative 10. So minus 9 and minus 1. So this means that x is either equal to 9 or x is equal to 1. And now we need to check. So in this case, we're not checking because of undefined. We're checking because we deliberately squared both hand sides. So we may have a case where we have one invalid solution. Okay, so let's go ahead and check. Okay, so you're going to take your original equation, and then in place of x, we're going to substitute these x values just to check if they both make, the left-hand side equal to the right-hand side. So this equation must be true. The left should be equal to the right. So in place of x here, I'm going to try 9 minus 3, and then 2 square root 9. 9 minus 3 is 6, and 2 times square root 9 is 3. 2 times 3 indeed is 6. So the left is equal to the right. X is equal to 9 is a valid solution. Okay, let's go ahead and try 1. So if you say 1 minus 3, you can already see how this is not going to work out. 1 minus 3 is negative 2. And then square root of 1 is 1. 2 times 1 is 2. Okay? Negative 2 and 2 are not the same number. So here we can see that x is not equal to 1. And there we go, x is equal to 9. And that is our answer. Moving on to the next question. Question 1.2.2 says, hence, and they give us this, if we are told that the cube root of 3t minus 2, and then the square root of the cube root of 3t, so something is repeating there, is equal to 3, determine the value of t. So this is a hence question, meaning this that they gave us is probably in a similar format to this, or really just the same format. Let's rewrite this again just to see. Okay, so compare these two equations. Do you see anything that is similar? So this says x minus 3. This says the cube root of 3t minus 2. Okay, so clearly they have switched something around. So the 3 is appearing here, but then here this thing with 2 is appearing on this side, okay, on the right-hand side. So let's do this first. If you take this, and we're going to keep this one the same because this is the original equation. I'll leave that one. But let's just take this. And we have the cube root of 3t. And let's bring that 3 over. So it comes over to become a minus 3 is equal to, and then take that over. So it's negative, it becomes positive, and it's the square root of the cube root of 3t. Okay, now do you notice a similarity between these two equations? Here you just have x. here you have the cube root of 3t. Then you have minus 3. Minus 3 is equal to 2 and then the square root of x. But here it's the square root of the cube root of 3t. What have they clearly put in place of x? They have put in place of x, okay, so I'm saying x actually stands for, in this equation, the cube root of 3t. Okay, so if I highlight it, you see that. See, there's x, there's x. There's the square root of x. There's the square root of cube root 3t. So that's all they did. Okay, so we're just saying x is actually equal to the cube root of 3t. So because the equations were in the same form, it means that whatever worked for this equation would work for this equation. So if x was equal to 9 was a valid solution here, then the cube root of 3t would also be equal to 9. Okay, so now we just have to solve for this equation. So what is t equal to if this is the equation we have? Well, there's a cube root, and we're trying to get to the t, so we need to get rid of that cube root. How do we get rid of a cube root? By cubing. What you do on one side, you must do on the other side. Okay, so we have 3t now because that cube root breaks open. And then let's just find out what exactly is 9 raised to the power of 3. It is 729. Okay, so 729, and then you're just going to divide both hand sides of this equation. So this, all of this divided by 3 is finally equal to, so t is equal to 243. And that is our answer for t. Moving on to the next question. Question 1.3 says solve simultaneously for x and y. And they tell us that, so we have 3y is equal to x plus 1. Do you see that x is on its own here? So we can actually make x the subject. Also, this is a linear equation. There's no squared or cubed or square root or xy. So we can actually make x the subject. So this will serve as our equation 1. And then the other equation, just take that as your equation number 2. Okay, I think this is one of those ones where they also repeat. And I think I've seen a question like this, a simultaneous equation question like this, where they factorize for you. So with this one, don't FOIL out, okay? It probably will not help you if you do that. It will be easier to use it like that. Okay, so let's just leave x on the right-hand side. And all we're doing is taking that one over. So we have x is actually equal to 3y minus 1. Because it comes over. So we can write it as x equals 3y minus 1. And so this is equation number 3. And to finally solve for y, we substitute equation number 3 into the equation we didn't use, equation number 2. So wherever you see x, replace it with 3y minus 1. Okay, so that is x, and that's 3y minus 1. And then we have minus y, okay, multiplied by 5y minus 3, and then x. So 3y minus 1, okay, is equal to 0. Okay, let's just simplify. So this is going to be 3y minus y, which is 2y, and then minus 1. And here we have 5y, and this multiplies in to become negative 9y, and then positive 3 is equal to 0. Just simplify further. And we have here, they would subtract to become negative 4y plus 3 equals 0. See why you don't have to FOIL in or start distributing? It's because these have already been put in brackets, meaning they've been factorized for you already, and one hand side is equal to 0. So you're saying something times something gives you 0. It's either the first is equal to 0, okay, or the second is equal to 0. So negative 4y plus 3 equals 0. And so we have 2y is equal to 1, divide both hand sides by 2, and finally y equals 1 over 2. Or, yeah, if you take that 4y over, it becomes 3 is equal to 4y, divide both hand sides by 4, and so y, okay, is equal to 3 over 4. Okay, so these are our solutions for y. And now we need to solve for x, because the question says solve for x and y simultaneously. So to solve for x, just find the equation that had x as a subject. And that was this equation number 3. X is equal to 3y minus 1. So take that. X equals 3y minus 1. So in place of y, we substitute 1 over 2. And then say, or x is equal to 3y again, 3 over 4 minus 1. And so x is equal to, that becomes 3 over 2 minus 1. But the denominators need to be the same for you to add or subtract. So I can change that to 2 over 2. So 3 minus 2 is 1. So that's 1 over 2. Okay. And then here, x is equal to, here they multiply to become 9 over 4. Change that so its denominator is 1. So 4 over 4. And so that's 5 over 4. 5 over 4. Okay, so these are our answers. X is either equal to 1 over 2, while y equals 1 over 2. Or x is equal to 5 over 4, while y equals 3 over 4. And that is it for this question. Moving on to the next question. Question 1.4 says the roots of the quadratic equation, and this is the quadratic equation they're given us. Okay, so you can see only c is missing. Okay, so a is there, ax squared plus bx plus c equals 0. Only c is missing. So the roots of this quadratic equation are x is equal to 3 plus minus 3 square root 5 over 2. And we need to determine the value of k. Okay, so they've given us the roots and then just an incomplete equation. So there's no problem with seeing the value of a, b, it's just c that we need to see. And we need to use this root, okay, the roots, to find it. Well, remember where the roots come from. Okay, they come from the quadratic formula. So where we say negative b plus minus the square root of b squared minus 4ac all over 2a. So the other ones, they're no problem. We can see what b is. It's consistent here. It's definitely negative 3, okay, because you say negative and then b. Okay, so b is negative 3. So that became a positive 3. That's fine. But we need to focus on the side that would help us find c. And that is specifically what comes after the plus minus, okay, because that includes c. So that is this part that says square root b squared minus 4ac. So that's what we need to look at. And you can clearly see that this is what it's equal to. So you have two choices. You can just think about it carefully, or you could have literally just said, okay, I'm going to take the square root of b squared minus 4ac and say this is exactly equal to 3 square root 5, because that's what it stands for. See, it's after the plus minus. Okay, and you could just solve for this equation knowing that you know what a and b are. Okay, so you didn't even need to think about nature of roots and how that worked. You could have just done this. Okay, it comes after the plus minus, so it's definitely that. Okay, now it's not just because it's after the plus minus, it's because we can see the consistency here. This was equal to 3, meaning yes, they actually did substitute negative 3 as the b value. So it became positive 3, okay, because of that negative in front. And then also just check that to make sure that it is consistent. So we have 2 multiplied by a, and a is clearly 1. So that's how they got 2 there. So it is safe to say that this is actually just equal to that. And we can solve. Okay, so it's the square root of, and what's b? b is negative 3, as we can see from the quadratic equation they gave us. So this is negative 3 all squared minus 4 multiplied by a, which is 1, and multiplied by c, which is a negative k. Okay, so that is square rooted. It's equal to 3 root 5. Okay, now let's go ahead and get rid of that third because it is distracting us from getting to this value of k that we're trying to solve for. See, when we square both hand sides of this equation, do you see how it doesn't affect the variable? So we don't even need to check if the solutions are valid here. It's still going to work. It's not tampering with the solutions. It's not like it's making k squared. Okay, so now there's an additional solution that we need to check whether it is valid or not. Okay, so negative 3 gets squared and becomes 9. And then this is negative 4 times 1, which is negative 4. Multiplied by negative k, which gives us positive 4k. And then this gets squared. So the 3 gets squared to become 9. The root 5 gets squared, and that breaks open, so it becomes positive 5. So it's still multiplying like it was here. They were multiplying. That's why they're next to each other. And so we can just say 9 plus 4k equals, that will become 45. I might as well just take that over. So this is 45 minus 9. Okay, 45 minus 5 is already 40, and then 40 minus 4 is 36. So this is 4k equals 36. Divide both hand sides by 4, and finally, k is equal to 9. Okay, 18, and then divided by 2 is 9. So there we go. That is the solution. K is equal to 9. And that is it for question 1.4, and that is it for question 1. Question 2.1 says, simplify the following fully without using a calculator. Okay, so with this, let me just rewrite what we have. Okay, so this is an exponential expression. So we need to focus on ensuring that we get their bases, okay, to become prime factors. So for example, with something like 2, you see that 2 is already a prime number. We can't really take it any further. But with 9, 9 has a factor 3. So we can express this as, so just leave this as 2 to the power of 4x plus 1. And 9 can be expressed as 3 squared. And this is still raised to the power of x. So when they multiply, it just becomes 3 to the power of 2x. And then the 6, you can break 6 up as 2 times 3. Those are two prime numbers. They're prime factors of 6. So that is 2 multiplied by 3. And then all raised to the power of 2x minus 1. We'll multiply that out. And this goes all over. We have 2 raised to the power of 6x multiplied by 27 can be written as 3 to the power of 3. And then we have multiplied by x in the exponent. And then times 3 to the power of x. And this is equal to. So focus on the numerator and the denominator separately. So if you see that things have the same base and they're multiplying, try to get them together. But of course, we need to still distribute there. Okay, so here we just have 2 to the power of 4x plus 1 multiplied by 3 to the power of 2x. And here, this has an invisible exponent of 1. So it's just going to be this exponent of 1 times this exponent. 1 times this would stay exactly this. So we have multiplied by 2 raised to the power of 2x minus 1. And then likewise with the 3, we have multiplied by 3 raised to the power of 2x minus 1 all over. Okay, so we have 2 to the power of 6x here. And then the 3 and the 3, the basis of 3 can multiply. So when they multiply, what happens with the exponents? They get added. So the bases are the same. So we add the exponents and we get 4x. And now we can finally focus on multiplying whatever has the same base. So that's the same base and the same base. So that is 2 raised to the power of. So that's going to be 4x plus 2x. That is 6x. And then 1 plus negative 1. See, if you say 1 minus 1, it's just going to be 0. So that's all that becomes. And then we are left with the 3 and the 3. So that is multiplied by 3 raised to the power of 2x plus 2x is 4x. And then plus negative 1, which is just minus 1 all over, and we rewrite. Okay, so these are exactly the same, so they cancel. And all you're left with is we have 3 to the power of, so these are dividing. If they're dividing, you're just going to subtract the exponents. So this is 4x minus 1 minus 4x. And so all we have is 3 to the power of, the 4x and the 4x cancel, negative 1. And 3 to the power of negative 1 is 1 over 3, and that is our answer. And that is it for this question. Moving on to the next question. Okay, next question. It is a bit blurry, so let me just rewrite it first. Okay, so this is what we have, and it is equal to, you see in the numerator, we have to take out the highest common factor. If not, we can't really factorize that or simplify it any further. So what we can do there is just look between 2021 and 2017 and see what is common. But if you didn't want to just jump into that, you could have also just checked what is going on here. We have the cube root of 3 raised to the power of 6048. When simplifying surds, you can just rewrite its exponent. So rewrite it as a base and then to the power of a rational exponent. So that would be, you take the inside exponent and you divide it by the outside exponent. And so we could rewrite that as 3 raised to the power of 6048 divided by 3. And then find out what that is. Okay, but 48 divided by 3 is 16. So this is 2016. That's what it will become, 2016. So what's actually best to take out as a common factor would be 2016, 3 to the power of 2016. Okay, so we see what that becomes. Okay, but we still need to take out a common factor. So what is left will just be simple numbers that we can simplify. So this is 3 to the power of 2017. And then what is left? So from 2017 all the way to 2021, we would add by 4. So this is 3 to the power of 4. And then minus, and you see this is just 3 to the power of 2017. And all we have to multiply to this to get back to that is just minus 1. Okay, so see, we can simplify those numbers. And so this is 60 multiplied by, and we know that becomes 3 to the power of 2016. Okay, so this is equal to, so these two, they would divide. Okay, if you say 3 to the power of 2017 divided by 3 to the power of 2016, because they have the same basis, the exponents will subtract. So if you minus, you see all that you'll be left with here is a 1. So that means this is 3 to the power of 1, which is just a 3. And then 3 to the power of 4 is 81, minus 1 is 80. And so this is what we have here in the numerator, 3 times 80. And then what was left in the denominator, it was the 60. Okay, so this is equal to, and now you can just divide. Okay, so I'll just cancel out 0. You can just use the calculator at this point, but 0 and 0 is gone. And then if you said 3 divided by 6, you get 1 over 2. And then you still have the 8 in the numerator. So 8 divided by 2 is 4. And our final answer is 4. Okay, and that is it for that question. Moving on to the next question. Okay, the next question says, solve for x without using a calculator. And we have m to the power of 8x minus 4 equals 1. Okay, looks very unusual because why do we have a variable and a variable? But they've used something very important here. They have used 1. What do you know about 1? 1 can be expressed in exponential form as any base to the power of a specific number. Anything to the power of 0 is 1. So that means to solve for this exponential equation, we can still make the bases the same. So this is m to the power of 8x minus 4. And we can just call this m to the power of 0 because it will still give us 1. Okay, so there we go. The bases are exactly the same. To ensure that this equation is true, the left is equal to the right, then make the exponents equal. So 8x minus 4 is equal to 0. Transpose to the negative 4, 8x is equal to positive 4. Divide both hand sides by 8. And finally, x is equal to 1 over 2. And that is our answer. Moving on to the next question. Okay, the next question, 2.2.2, says we need to solve for x in this equation. And this is an exponential equation. And let's just focus on the amount of terms we have first, because there's something repeating all through. You see that terms are separated by plus or minus signs. There's a minus sign, there's a plus sign. So it means you have 1, 2, 3 terms on the left-hand side. And what you notice about these 3 terms is they all have a 3 to the power of x. 3 to the power of x. So we can actually take 3 to the power of x out as a common factor. And then what are you left with in the first term? You'll just be left with a 4. And in the second term. So with this one, the reason these two are together is because they were actually, so minus and 3 to the power of x. Now, the only way you could have gotten those exponents to come together like that is if you had 2 bases with 3 and then this exponent was a negative 2. So if the bases are the same and you're multiplying, you would add the exponents, and so they became x plus negative 2, which is just an x minus 2. And so it means that all that is left, as you can see, would have been the minus first and then the 3 to the power of negative 2. Okay, and then in the third term, what is left? Well, it's the exact same thing. So the only way you would start here and multiply something to get back to this is if you multiplied it by 1. Okay, so that's all that's left. It's equal to 44 over 3. Now, the good thing about this is now the 3 to the power of x, okay, the value of the variable in the exponent has been isolated. And all we have here are numbers. So we can just rewrite this as 3 to the power of x. And we have, so this is 4 plus 1, which is 5. And then minus, if you say 3 to the power of negative 2, it's the same thing as saying 1 over 3 squared, which is 1 over 9. Okay, so minus 1 over 9, and then it's equal to 44 over 3. And then just simplify that. If you say 5 minus 1 over 9, you're subtracting fractions, okay, or by a fraction. So the denominators need to be the same. So if you multiply this by 9, 9 times 5 is 45. And then if you subtract, that's going to be 44 over 9. So this is 44 over 9. And then this is 44 over 3. Interesting. So now we can finally solve for x, okay, or get 3 to the power of x alone. And you can divide both hand sides by this number. Or you could simply multiply both hand sides by its reciprocal. So swapping the numerator and denominator. So 9 over 44. And then multiply by 9 over 44. Because what will happen is the 9 here would cancel, okay, numerator and denominator, and then numerator and denominator. So all you're left with is 3 to the power of x is equal to, and then here you see that 44 and 44 cancel, and now you have 9, okay, and then over 3, which is equal to 3. And finally, to ensure that the left is equal to the right, the only way these are equal is if the exponents are equal. So x is equal to the exponent of 1, okay, the invisible exponent of 1. And that is our answer. Moving on to the next question. Question 2.2.3, we have been given x to the power of x is equal to 2048. So we need to solve for x. So what to the power of what is equal to this number? How can we express this number as a number to the power of the same number? Okay, so we're just going to think about how we can break this up. So I'm going to try and find a way to show that there are two numbers, okay, that we raise, but not by guessing. You just need to try and figure it out. Let's just understand how these numbers would work. It's really just dependent on this. Let's focus on that part. I'm going to look at 2 to the power of 2048, and let's see how we can rewrite this. So it's 2 to the power of a value. But then with this number 2048, I think at this point we can sort of use a calculator because, so I'm looking at 2048 and I want to just see what its factors are. Okay, what exactly are we multiplying to get to that number? So it's equal to, and just say shift fact, and it's 2 to the power of 11. Okay, and that's all I need for that. I just need to find out how we can share it. So this is actually 2 to the power of 2 to the power of 11. Okay, because 48 is 2 to the power of 11. So I want to share the exponents in a way that this base becomes exactly the same thing as this base. So I'm going to try to express them both in exponential form because I think that will be the quickest way to get to this. Okay, let's see what we can do. If I decided to take a 2 out of this, and what I mean by taking out a 2 is, for example, if I decided to remove a 2 from here, it's like taking it out as a common factor. That's really what it is, taking it out as a common factor. So with the actual number, if I took 2 out as a common factor, you'd be left with 1024. But I don't want to work with numbers like this because they're a bit intimidating. I would rather work with it in exponential form, and then I can clearly see if they end up being the same. But now this is what I'm going to have to think of. If I need to keep expressing it in exponential form, if I'm taking out a common factor of 2 here, if you have 2 to the power of 11, and you say take out a common factor of 2, what is left? It would be 2 to the power of 10. But then this 2 is now going to go here on this 2. It gets squared. So this 2 is now raised to a 2. Okay, so it's like this. 2 to the power of 2 is now raised to 2 to the power of 10. And then this is still the same number. Because remember that this 2 is an exponent. If it multiplies back, it's going to be 2 times 2 to the power of 10, which is 2 to the power of 11. Okay, the bases are the same. If you're multiplying those, then you would add the exponents. Okay, so in this case, it will just become 2 to the power of 11. So I want to get it to the point where this, okay, says the exact same thing as that. So it's 2 to the power of a number and then 2 to the power of the same number. And then I know it's the same. Okay, so with this, we're going to have to just be very careful. When we take out a 2 here, we're taking it out as a common factor. Okay, so the exponent here becomes 1 less. So I have to remember that. The exponent will become 1 less when a factor of 2 is taken out. However, when that exponent goes here, what will happen is I'm not expressing this as 2 to the power of something because then you see this already has a base. So this one, when we take out a 2, it actually multiplies to this. Here's an example of what I mean. If I say this is 2 to the power of 2, and now let's say we take out a common factor of 2 from here. Okay, so a common factor of 2 comes out. What are you left with? You're left with 2 to the power of 9. And so what does this 2 do? This one. It's going to multiply with this 2 here. Okay, because if you have 2 squared all raised to the power of 2, we're leaving this out for now. Then that becomes 2 raised to the power of 4. Okay, so long we have 2 raised to the power of 4, and then that is raised to the power of 2 to the power of 9. Okay, I'm still trying to make sure that this base and exponent says the same thing as this base and exponent. So all we're doing here is when we take out a common factor of 2 from this base, it makes the exponent 1 less, but then that 2 will multiply to this over here. And so look at what happens. I'm going to take out that 2 again. So now we have 2 raised to the power of, now what does the exponent do when it comes here? Remember, it's going to be 4, but you're taking out a common factor of 2 here. So if you take out that common factor of 2, you're left with 2 to the power of 8, and this 2 multiplies with this 4. So now we have 2 to the power of 8 raised to the power of 2 to the power of 8, and this is it. Okay, so we just have to find out what exactly 2 to the power of 8 is. And 2 to the power of 8 is 256. So it means that all of this, and yeah, you'll probably have to write it like that, line by line. Okay, so I'll take that out and I'll just put x to the power of x. Okay, so just expressing this. Okay, so it just means that x to the power of x is finally equal to 256 to the power of 256. Therefore, x is equal to 256, and that is our answer. Okay, and that is it for question 2.2.3, and that is it for question 2. Question 3 says the function g is defined as g of x is equal to 1 over 2 raised to the power of x minus 4. And 3.1 says, write down the equation of the asymptote of g. Okay, so this is an exponential equation. So it's written in the form of y equals a multiplied by a base raised to the power of x minus p plus q. So the only reason we can't see that minus p value there is because there was no horizontal shift. But with the exponential function, how we know the value of the asymptote, it only has one asymptote, and it's specifically a horizontal asymptote. Remember that horizontal lines, their equations start with y is equal to. So it's simply y equals whatever y value they pass on the y-axis. And so that is this value of q. Okay, so you're always just going to say y is equal to whatever your q value is. We can see that's negative 4. So y is simply equal to negative 4. And this is our answer. Moving on to the next question. Question 3.2 says, calculate the y-intercept of g. So the y-intercept is the point where x is equal to 0. So take the graph of g. So we're saying g of x, but in place of x, substitute 0. So this is equal to 1 over 2 raised to the power of 0 minus 4. And you know that anything to the power of 0 is equal to 1. And so minus 4, and that gives us negative 3. So g of 0 equals negative 3, meaning our y-intercept is negative 3. And that is our answer. Moving on to the next question. Question 3.3 says, calculate the x-intercept of g. Okay, so you see with all the things they're asking, they're probably going to ask us to sketch this graph. So to find the x-intercept, this is the point where y is equal to 0. So take your graph of g of x, but you know that g of x stands for y. So this is 1 over 2 raised to the power of x minus 4. And in place of g of x, y, we're just going to substitute 0. Okay, so here, to solve for x, we can just transpose this negative 4, so it's positive. We have 1 over 2 raised to the power of x. This is an exponential equation, so we need to solve for x. How do we get to the x? We can get to the x by making the bases the same. So this is a 1 over 2. How can we rewrite this base of 4 as 1 over 2? Well, 4 is 2 squared. And we know that we can write 2 as a half if naturally, okay, 2 has an exponent of 1. You can just rewrite it as 1 over, but what you're really doing is 2 to the power of 1 is in the numerator as a fraction. And so you're just moving this to the denominator, but then that will cause its exponent to become negative. Okay, so it's negative 1 and you still have 1 here. It's not this 1 here, it's actually the invisible 1 in front of this 2, okay, because they don't switch places. So we know that 2 can be written like this, okay? And so that means this 2 squared can be written as 1 over 2 raised to the power of negative 1, okay? But you know that 1 to the power of anything would just stay the same. So even if you said 1 to the power of negative 1, it's still 1. And so we can actually rewrite this as 1 over 2 raised to the power of negative 1. So to ensure that it is still 2 squared, okay, so this is 1 over 2 raised to the power of negative 1, you just raise it to the power of 2. And so we just have 1 over 2 raised to the power of negative 2. That is 4. Okay, if you put that back on the calculator, you will get 4. So this is 1 over 2 to the power of negative 2, and that is equal to 1 over 2 to the power of x. And now the bases are the same. You can equate the exponents, so x is finally equal to negative 2. And that is our x-intercept. Okay, moving on to the next question. Question 3.4 says, draw a neat sketch of G, clearly show all intercepts with the axes and then the asymptote. Okay, let's go ahead and put down our Cartesian plane, and then we can also put down the asymptote. Okay, so that's what you start with. Start with the asymptote. Now, before actually drawing this, you can actually consider what the asymptote looks like. It says negative 4, okay, y equals negative 4. So it's going to be a line. So with this one, this is actually fine for it. You can go ahead and draw a line, y equals negative 4, a horizontal line, and either show that it passes negative 4 on the y-axis or write y equals negative 4 so they know this is the asymptote. Okay, so this is what we have. And now let's go ahead and put down our intercepts. So we have an x-intercept of negative 2. So negative 2, meaning as an x-intercept, that's negative 2 and 0. So we're going to go negative 2, okay, 2 units to the left, so that's negative 2. And then we have a y-intercept of negative 3. So it's on the y-axis, just go 3 units down. So there we go, that's negative 3. And now we need to draw our graph. So we can see the shape of our graph because of the value of a and b jointly. So the value of a alone, all it tells you is whether your graph lies above or below your asymptote. So you have an asymptote, and if a is greater than 0, your graph lies above the asymptote. So it could either look like this as a decreasing function or like this as an increasing function. If it's less than 0, it lies below the asymptote. So it could either look like this as an increasing function or like that as a decreasing function. Now, what will tell you whether it's increasing or decreasing is the value of a and b together. So you see, that doesn't really have to do with this. All you have to look at is what this part is doing. So here, I know it looks like there's no value of a, but there actually is. It's an invisible 1. Okay, so how you can find out whether it's increasing or decreasing is like this. A simple way is to take two x values that come right after each other, like x is equal to 1 and x is equal to 2. And we're going to find the corresponding y values for these and judge whether it's increasing or decreasing. Okay, so if you try 1 here, 1 over 2 raised to the power of 1 is 1 over 2. Then if you try 2, 1 over 2 raised to the power of 2 is 1 over 4. So from this point to this point, did the graph increase or decrease? It decreased, okay, because 1 over 4 is less than 1 over 2. So you know it's a graph that lies above the asymptote, okay, because a is a positive value. It's a positive invisible 1. And this is decreasing, meaning it's going to be decreasing. So there we go. We know it looks like that. Okay, let's go ahead and put that there. So we know that our graph, see, and that makes perfect sense. It's going to do this. So hit there, hit the y-intercept and move closer and closer to the asymptote, never touching it. And this is our graph. Okay, this is the graph of G. And that is it for question 3.4. Moving on to the next question. Question 3.5 says, calculate the average gradient of G between x is equal to 0 and y is equal to 0. Okay, so they didn't say x is equal to 0 and then x is equal to no. Okay, so they said x is equal to 0 and y is equal to 0. But you can just think about these as, where is x equal to 0? X is always equal to 0 at the y-intercept. Where is y equal to 0? At the x-intercept. So they just want you to find the average gradient of G, okay, between the x and the y-intercept. That's all. Okay, so we're going to have to take the corresponding y value. So it's just gradient, meaning to find the average gradient, we just say the change in y over the change in x. So that is going to be, let's take the y-intercept's value, okay? So it's going to be change in y, meaning take the y value here minus the y value here. So just remember what this point is. This is negative 3 as a y-intercept. So this is 0 and negative 3, okay? You know the point. And this is negative 2 and 0. So this is y2 minus y1. It's just going to be negative 3 minus 0 over x2 minus x1, which is 0 minus negative 2. Okay, be consistent. If you say this minus that, you need to say this minus that as well. Okay, so this is our point 2 and point 1. Okay, the other way around would also work. So this is what we have, and it's just going to be negative 3 over, and that becomes positive 2. So that is the gradient. Okay, the average gradient between those 2 points is negative 3 and 2. And that's our answer. Moving on to the next question. Question 3.6 says, write down the equation of k if it is given that k of x is equal to g of x plus 4. Okay, just take it literally. It says k of x is equal to g of x plus 4. What is g of x equal to? They told us initially g of x is 1 over 2 raised to the power of x minus 4. So we replace it with this. Okay, so we're saying k of x is equal to input g of x. It's 1 over 2 raised to the power of x minus 4. And then just say plus 4. Okay, so k of x is equal to 1 over 2 raised to the power of x, and that is k of x. Moving on to the next question. Okay, so looking at 3.7, the last question for question 3, it says, it is further given that h of x is equal to 2 to the power of x plus 3 minus 4. Explain in words how graph G must be transformed to obtain graph H. Okay, so we had g of x, and let's just rewrite that. You can see that g of x from here, it is just 1 over 2 raised to the power of x minus 4. And what they're saying is this graph is transformed and then it becomes h of x, which is 2 raised to the power of x plus 3 minus 4. So how do we get the equation of g to end up looking like the equation of h? Okay, so there's a clear problem here that we need to work on first. Do you see how we have a half as the base here, but then here we have 2? So that needs to change. So the only way to get a half to become 2 is if we rewrite it like this. So instead of writing it as 1 over 2, we can move that 2 in the denominator up to the numerator, and it becomes 2. And of course, what is going to happen because you moved it is the exponent becomes negative, and then it's still raised to the power of x. So if you multiply, this is actually negative x. So it's 2 to the power of negative x and then minus 4. Okay, so this is not changing anything. We're just changing the way it looks. Okay, so no transformation has happened yet. Okay, so now we have this 2 and this 2. But then do you see what's going on here? You have a positive x and then plus 3. So let's see. The minus 4 and the minus 4, they're fine. So how can we get this to say positive x? The only way to make it positive is by multiplying that x by negative 1. So I'm taking the x specifically, and I'm saying x times negative 1, which gives us negative x. So I'm making the x negative. And so this is 2 to the power of, and we still have a minus there, and the x is just becoming negative. Okay, so that becomes negative x. Okay, so it's really just seeing it as in place of x, just substitute negative x, because this was g of x. Now it's g of negative x. So wherever you see x, replace it with negative x. Okay, so long, this is just going to say, let me just rewrite. It's just saying 2 to the power of positive x. And then, of course, we still have the minus 4. Okay, so now what is the next step to get it to look like that? You see that a 3 has been added to the x. And in this case, it's simple to do that because we just have x here. So in place of x, we are just going to substitute x plus 3. Okay, and so we're going to have to discuss what this actually means. So if we were applying this to an equation, I'm not really going to call it g of x anymore because it's been transformed. We're just going to still have to understand what exactly this means, okay, to make that negative. But if we were applying it, let's say it was an equation of k of x, we would say k of, let's say the new equation is called k of x, right? We would say k of x plus 3. So it means that wherever you see x, simply replace it with x plus 3. So this is equal to 2 to the power of, and this becomes x plus 3, and then minus 4. Okay, and so that would be the new equation. So that is the equation of h, and now they look identical. So now we just need to speak about everything we did. We said minus x first, okay, so multiply the x by negative 1, and then we added a 3 to the x. Okay, I'm just going to leave this here just for explanation's sake. Okay, now look at what this means. Let's speak about this negative x first. If we have x values, negative x would mean that you took all the x values of the graph and you multiplied them by -1. So let's just look at what it means if we had a point and then we multiplied its x value by -1. Say we had this point A and it's 2 and 1. And then we take that x value, only the x value, and we multiply it by -1. It'll become -2. So if you plot this point, it is -2 and 1. Okay, so it appears here. And so this is -2 and 1. When you look at these 2 points, what happened? How do we get this point to appear over here? We would have done that by reflecting it. Now, do you see that because it was here and now it appears here, it means it was reflected through the y-axis. Okay, so that's what happened with that -x. We know that G was reflected across the y-axis, okay? And then we have this +3. So what happens when you say x plus 3, but specifically in the equation? Okay, this is very different to taking a point and then adding 3 to the x value because we're saying x plus 3. Okay, it's very different. If you just take a point and you add 3 to the x value, it's going to cause this point to shift 3 units to the right. But when applying this to an equation, okay, if you ever see k of x and it says x plus 3, then what it means is that because it says plus, we're directly adding to the x. So this is a left or right movement. But because it says plus, this is a left shift, okay, a left movement. So this means that this graph was reflected across the y-axis and then it was shifted 3 units to the left. Okay, and that is what happened. Okay, so it was reflected across the y-axis, shifted 3 units to the left to obtain h. Okay, and I'll leave it like that in that order. So that's how we get this to look like that. And that is it for question 3.7, and that is it for question 3. Question 4 says, the function f of x is equal to a over x plus p and then plus 1. Okay, so they only give us that. Has an axis of symmetry with an equation of, okay, x is equal to 3 minus y. You just have to put it in, its standard form. Y is equal to. And 4.1 says, write down the range of f. Okay, there's only one thing we need to find the range of a hyperbola. Okay, so with the hyperbola, all we're thinking about is it doesn't even matter whether a is positive or negative. Okay, if a is positive, then the graph will lie in the first and the third quadrant. But here's the thing with the range. The range refers to all the possible y values of this graph. So all the y values it has. You see that the y values lie on the y-axis. If you're looking at all the y values a hyperbola has, you're going to look at it like this. See, look at this point. Look at the y value. Look at that point. Look at the y value. It's going to have y value in almost every place, okay? Almost every y value that exists, it will have it, except for one place. So this is specifically where the graph will never pass. And it will be specifically where the graph will never have a y value, which is the horizontal asymptote. And that equation is y equals q. Okay, so q being whatever we have here. Remember that the hyperbolic function's equation, its general form is y equals a over x minus p plus q. Okay, so q is that y value. So all we have to say here is it has every y value. So y is an element of all real numbers. As long as it's a real number, it has it, except for where y is equal to 1. Okay, so y would just not be equal to 1. And that is our answer. Moving on to the next question. Question 4.2 says, determine the equation of the vertical asymptote of f. Okay, so from the previous question, you can see the horizontal asymptote is at y equals 1. And so to find the vertical asymptote, you can see they didn't really give us the value of a, so you can't really use that and any points or anything like that. So what we could use is, let's use this. You see, this is the axis of symmetry of this equation, but it's just not in standard form. So x equals 3 minus y, and let's put it in its standard form. So right now the y is negative, transpose it to make it positive. And so then the x goes over and becomes negative x plus 3. So this is the equation of the axis of symmetry. So with this axis of symmetry, there's actually something that can help us find the vertical asymptote. And let's just point out what exactly that is. So you see in the general form of a hyperbolic function, do you see that that is the value of the vertical asymptote? That's the value of p. Remember that. So if this is p, yeah, their p there is different. We're just going to focus on this one so we can actually find that vertical asymptote. So with this, we can actually focus on the general equation of the axis of symmetry of a hyperbolic function. So a hyperbola has two axes of symmetry, okay, regardless of whether your graph is in the first and the third quadrant or the second and the fourth quadrant, there are two axes of symmetry. There's one with a positive gradient, okay, and that one, its equation is this. All you have to remember is the general form of your hyperbola. Okay, if you remember this, then that's literally it. It is y equals positive x minus p plus q, okay? So that is the one with a positive gradient. Now, the one with a negative gradient, which is clearly what they've given us, because you can see the gradient, okay, y equals mx plus c. The gradient is negative here. So the one with a negative gradient, this is how we get that. You say y equals, and all you have to do is put a negative in front of x and p. So when you do that, you get x minus p and then plus q. And if you distribute, you get negative x plus p plus q. So if we know that this is the general form, but we know the value of q, we know the horizontal asymptote. It is 1. Okay, that's why the range looks like this. Okay, so here's the thing about this. There's some things we know here. We know the general form of the axis of symmetry of a hyperbola with a negative gradient is y equals negative x plus p plus q. And we currently know that the value of q is 1. Okay, so how did they get this equation, okay, in its general form to end up looking like that? If you know that q is 1, just substitute 1 in place of q and then you'd see what they did. This was negative x plus p and then plus 1. Okay, so what did you do to get it to look like that? What should p be for us to get this? P should clearly be equal to 2, because you'd say negative x plus 2 plus 1, and then 2 plus 1 give you 3. And that's how we would get that 3 over there. So P is simply equal to 2. P is equal to 2. And what does P stand for? Remember, in the general form of this P, okay, I'm not talking about their P, this P. So in the general form, which is written like this, there must be a minus in the middle. This P stands for the vertical asymptote. So if it says x minus, for example, x minus 2, which we can see it is x minus 2, then the equation of your vertical asymptote, it's a vertical line. Vertical lines equations always start with x is equal to, and then it's x is equal to whatever x value they pass on the x-axis. So in this case, we can see that the vertical asymptote's equation is simply x is equal to 2, and that is our answer. Moving on to the next question. Okay, so we know the value of p now. Of course, we'll have to just be clear if they ask us for the value of p, what exactly their p is. Okay, but moving on to the next question. Okay, question 4.3 says, if f of 0 equals 2, calculate the value of a. Okay, so let's take our equation, put it down, because we're going to need it since they're telling us something here. And we're also going to take note of all the other things we found, q is equal to 1, p, the original p of a hyperbola is 2, and so on. So let's put that down. Okay, so you know that this is already 1, and in its general form, okay, what this is supposed to be, we now know it should be x minus p, but we found that p is 2, so this should be x minus 2, okay, if we update this equation. And now what they're telling us is f of 0 equals 2. What does that mean? Well, you see when we say f of x, this is x. They have said f of 0. So it means that in place of x, they substituted 0. So this means that this is a point with an x value of 0. And then they said f of 0 equals 2. So once we substitute an x value of 0, we get an output or a y value of 2. So the y value is 2. They substituted a point 0 and 2, which is clearly a y-intercept. And all we have to do to find a is simply fill in that y value, the x value, and then you'd solve for a. Okay, so substitute this point in place of x and y, and we would solve for a. F of 0 is equal to a over, and then in place of x, you say 0 because you said f of 0, minus 2 plus 1. And then what is the value of f of 2? It's 2. So 2 equals a over, and then 0 minus 2 is negative 2, then plus 1. And then solve for a. So how do we get to a? Well, we can get to a by taking 1 over first. 2 minus 1 is 1. And you have a over negative 2. Then finally solve for a. Just get rid of the negative 2 in the denominator by multiplying both hand sides by negative 2. They cancel here. So therefore, a is equal to negative 2. And that is our answer. Okay, moving on to the next question. Question 4.4 says, calculate the x-intercept of f. So x-intercept, we find that by making y equal to 0. Okay, so our equation is now complete. We know now that f of x is equal to a is negative 2 over, and now we just say x minus 2 and then plus 1. So make y equal to 0. 0 equals negative 2 over x minus 2 plus 1. Then solve for x. Okay, this is negative. Might as well take it over. So the numerator, really, this whole fraction is negative. Okay, I just put the negative here. It's all negative. When it comes over, it becomes positive. And then it's positive 2 over x minus 2. Okay, and then it's equal to 1. And now we can cross multiply just because we have this denominator. So put this over 1 and cross multiply. X minus 2 times 1 just stays x minus 2. 2 times 1 stays 2. Then transpose that, negative 2, x is equal to 2 plus 2, which is 4. So that is the x-intercept. They didn't say as a coordinate, so we'll leave it like that. X is equal to 4. Moving on to the next question. Question 4.5 says, draw a neat sketch of f, clearly showing all intercepts with the axes and the asymptotes. Okay, so we need to draw a sketch. Do we have all our intercepts? Let's just name the things that we have. So to draw a hyperbola, we're just going to say, first, let's consider the shape of the graph. The shape depends on the value of a, okay? If a is, let's just look at what a is. A is negative, okay? Because we saw it was negative 2. A is less than 0. This means that your graph is going to lie in the second and the fourth quadrant. And then let's also just consider our asymptotes. So it's a hyperbola. It has two asymptotes. So it has a vertical asymptote, which starts with, it's a vertical line, okay? You just have to see which axis does it cross. It passes the x-axis. So it starts with x is equal to. So vertical line, the vertical asymptote, we see that, okay, that's the value of p, okay, x minus p. So x is equal to 2 because this is x minus p. So p is 2. So that is x is equal to 2. And then what is the horizontal asymptote? That is a horizontal line. Remember, it passes the y-axis. So it starts with y is equal to. And it's always going to be y is equal to whatever this value of q is, okay? And so that is y is equal to 1. And that's our asymptotes. Those are our asymptotes. And then we have intercepts as well. So number 3, our intercepts. So we have an x-intercept, which they just told us to find. It's 4. So as a coordinate, it's 4 and 0. And we have a y-intercept, which I think we found a y-intercept. Oh, they told us a y-intercept. 0 and 2 is a y-intercept, okay? F of 0. So this is where x is equal to 0. That is a y-intercept. So that is 0 and 2. We have everything we need to draw this graph. So let's put down a Cartesian plane. And first put down your asymptotes so you know where not to go beyond. So our asymptotes are x equals 2. That is the vertical one. So line down and just show that it passes 2, or at least write x is equal to 2 so they know. And then we have y equals 1. That is the horizontal asymptote. So a line passing 1 on the y-axis. So y equals 1, and that's 1 over there. Okay, so there we go. And now let's put down our intercepts. So we've got 4 and 0 as an x-intercept. So on the x-axis, we have 4 and 0. And then on the y-axis, 0 and 2. So 0 and 2. And then just draw your graph. You know the shape already. So we can have a wing here and another wing here. Okay, so this first wing should not go past this. Okay, so it comes from this side. It comes from being close to the asymptote, passes 2, moves closer and closer to that asymptote, never touching it. Okay, and then the other wing does, the same thing really. It comes from being really close to the asymptote and then moves closer and closer, passes 4, moves closer and closer like that. Okay, so there we go. that is the graph of f that has been sketched. They can see the shape, your intercepts, and your asymptotes. And that is it for this question. Moving on to the next question. Question 4.6 says, write down the values of x for which f of x is less than or equal to 0. Okay, let's just speak about what this means first. So f of x refers to y values. So they're asking you to tell them the values of x for which your y values are less than or equal to 0. Let's speak about less than 0, where f of x is less than 0. So when f of x, meaning the y values of this graph, are less than 0, look at which axis are you going to focus on? You'd focus on the y-axis because this is where we have y values. So y values that are less than 0 are down here. So you'll be looking for parts of the graph that lie specifically here below the x-axis because this is where you find negative y values. Okay, and that's what we're going to do here. So just also remember, we're also going to look for where f of x is specifically equal to 0. So where is the y value equal to 0? Of course, that is at the x-intercept. So look at the graph of f and you're going to look for points on the graph that lie below the x-axis. That all the way there is below the x-axis. Everything here is above the x-axis, okay? Even this part, it's above the x-axis. Here's your x-axis, it's above. Okay, so tell them the values of x for which this section that has been highlighted exists. What are the values of x? You could find this by lining these. So these are all little points here. If you line it up to the x-axis to understand what exactly their x values are, can you see that there are values that are moving to the right-hand side of 2. So 2 is clearly a marker here. We can't go beyond 2 because there's an asymptote here. So there are values that are greater than 2, but less than 4. But we need to consider here. You see at 4, this point is 4 and 0. It has a y value equal to 0. They said f of x needs to be less than or equal to 0. So we would also have to include the x value of 4, meaning our answer here is going to be, this is where x is, as you can see, it's values that are greater than 2, so greater than 2, but less than or equal to 4. So values that are less than or equal to 4. Okay, so less than or equal to 4, and that would be our answer. Okay, if you wanted to write this as intervals, you could just say x is an element of, in interval notation, this would be, it's going from 2 all the way to 4, but then 2 is not an included value because there's an asymptote there, so use a round bracket. 4 is an included value, so use a square bracket, and then that's what that looks like. Okay, moving on to the next question. Question 4.7 says, the straight line y equals negative 2x plus 5 passes through the point of intersection of the asymptotes and intersects f at P and Q. Write down the coordinates of Q. Okay, for 2 marks, this doesn't really seem like something they would do for 2 marks, but let's just put down everything we have. So they say there's this straight line, y equals negative 2x plus 5. Okay, so there's a line, y equals negative 2x plus 5. Now this line passes through the point of intersection of the asymptotes. Okay, so the asymptotes, remember where they were. Okay, I don't want to actually just, take this whole graph. We can't just put down the hyperbola quickly. Let's just put that down. Okay, so the hyperbola, remember it has a vertical and a horizontal asymptote. So that's x equals 2 and y equals 1. So if we have that over there as x equals 2 and y equals 1, this is what is going on. Okay, so they're saying that this line, okay, which is negative x plus 5. So it's not that axis of symmetry with a negative gradient. It's just another line completely. Okay, and it clearly has a steeper gradient. So it's like we have a line like that and it passes 5 on the y-axis. So it's just raised up a little bit. And so we have this line, it's y equals negative 2x plus 5. And it passes through the point of intersection of the asymptotes. Okay, so this passes this. I noticed that I was putting it in the wrong place. So it passes the points of intersection of the asymptotes. I should have changed the color of the asymptotes so I can, clearly see them. It's this and that. Okay, so we have that it passes through the point of intersection of the asymptote. So it means that we know one point that it passes. it passes this point, which is 2 and 1. Okay, that's the point that it passes. And then it intersects F at P, which is 1 and 3. So remember that this is our graph. Okay, it lies in this quadrant and this quadrant. So we have that. And we just know that all we know about this point they're referring to is it passes through the actual graph. So it intersects F at P, which is 1 and 3. So I'm guessing that's up there. That's 1 and 3. And then at Q, and that's what we're trying to find, Q, the value of Q. Okay. Okay, so to be honest with this, I don't really see how this helps to find it. Okay, because even if you found the equation of this line, how do you know where it intersects with this graph? Unless you actually take the equation of this and you equate it with the equation of F. Okay, there's no rule that actually states that, we'll be able to find that. Because here's the thing, and it looks like this is what this is focusing on. It looks like they're saying that this is maybe the midpoint of these 2 points. But I can't really go with that because it maybe it is the midpoint. However, there's one line that we know that this point 2 and y will always be the midpoint of, and that is the axis of symmetry of your hyperbola. So if you have an axis of symmetry, which we did have, okay, we had the one with the negative gradient, okay, if you check the points where it intersects the graph of f, those 2 points, if you find the midpoint of that, it would be this. Every other line, naturally, okay, we can't really assume or say for certain that it will have this midpoint, okay, when it intersects the graph, okay, of f at 2 points. And then we can't for certain say that this will definitely be the midpoint, okay. That symmetry only works with the axis of symmetry. So the only logical way I can see that we can actually just approach this question is to simply just equate those 2 functions. You know that you're trying to find Q, which is really just the other point of intersection. So they say we have one point of intersection here, and then we need to find the other one. So it's a point of intersection between F and this line they gave us the equation of. So I'm just going to equate them. So f of x is equal to those negative 2 over, and it's x minus 2 plus 1. And I'm going to equate it with this. Okay, so we're making y equal to y. F of x stands for y. So we'll just say negative 2x plus 5 is equal to, yeah, and that's why I feel like this question for 2 marks, not sure. Okay, I'm not sure why it's 2 marks. So this, and then we can take that one over. So negative 2x, and then if you say positive 5 minus 1, it gives you 4. So positive 4 is equal to negative 2 over x minus 2. Okay. Now, let's go ahead and cross multiply. So I can put this over 1. And then if we cross multiply, we're going to get negative 2. And here, well, I see something we can do here. We can take out a common factor of negative 2. It will look a lot like this because I can see here, if you just multiply this by 2, or negative 2 really gets to this. Multiply this by negative 2, it will get to that. So take out a common factor of negative 2 here. What do you have left? Negative 2x divided by negative 2 is positive x. This divided by negative 2 is negative 2. Is equal to negative 2 over x minus 2. Now we can cross multiply. Okay, so if you cross multiply this multiplied by this, you can see that we have x minus 2 and x minus 2. They will become x minus 2 squared. So you have negative 2 times x minus 2 all squared is equal to 1 times negative 2 is negative 2. Then get rid of the negative 2 by dividing both hand sides. Therefore, x minus 2 all squared is equal to 1, and then square root both hand sides. So square root and square root, but you need to consider the positive and negative solution here. So x minus 2 is equal to positive or negative 1. Therefore, x is either equal to, transpose that, that becomes positive 2, and it's plus minus 1, so it's plus 1, or x is equal to positive 2 minus 1. So we're just taking that over. So we had x is equal to 2 plus minus 1. Okay, so that is just distributing that plus and minus. So here, and we're just wrapping up now, x is equal to 3 or x is equal to negative 1. So now we need to choose which one we go with. Remember, we actually have one point of intersection, that is P. We know that this is 1 and 3. See, the x value is 1. So we're not going to go with the 1. And I notice I said minus 1. This should be 1. Okay, 2 minus 1 is 1. Okay, so we're not going to go with that one. We're going to go with the 3. because that's the other point of intersection. So to find this, just use the easier equation. Since they both intersect at Q, this point Q lies on F and this line. So I'm going to go ahead and say y is equal to, and we have -2 multiplied by 3 and then plus 5. Okay, so y equals, this is -6 plus 5, so 5 minus 6 is -1. Okay, so yeah, I should have probably just put that here. So there we go. That would be Q. That's the other point. Q is therefore, the x value is 3 and the y value is -1. And that is our answer. So that is our answer. Okay, Q is 3 and -1. And that is it for question 4. Question 5 says the graphs of h of x, which is a parabola, as we can see, and p of x, which is a straight line, are sketched below. The x-intercepts of h are -3 and 0 and 1 and 0, and the y-intercept of h is 6. M is the turning point of h. D and E are the x and y-intercepts of p, respectively. Okay, so D and E. And then the first question, 5.1, says, write down the coordinates of D. So that is the x-intercept of the graph of P. So we have the full equation of P of x. So P of x is equal to 8 minus 2x. And D, as we can see, is the x-intercept. This is the point where y is equal to 0. So just make y equal to 0. And we have 8 minus 2x. Transpose this to make it positive. So it's 8. Divide both hand sides by 2. And therefore, x is equal to 4. So the coordinates of D, they ask for coordinates, that is going to be 4 and 0. And you can just put that down. That's 4 over there. Okay, so that is our answer. Moving on to the next question. Question 5.2 says, show that A equals -2, B equals -4, and C is equal to 6. Okay, so that's A, B, and C in our parabola. Okay, so it's in its standard form, and you know that in its standard form, the value of C is your y-intercept. Okay, so that is C over there. That is 6. So we can already see that. We can state C is equal to 6. As we can see, this is the y-intercept of F. Okay, that was already stated. And now to find the rest. You see, you just have to look at your graph and just see what they gave you. They gave you a y-intercept and then they gave you x-intercepts. If they give you this in this format, just go ahead and use the x-intercept form of this. So the x-intercept form of the parabola, which is, it's f of x, I'll just call it f of x is equal to, and we say a multiplied by, and this is x minus the first root, okay, or the roots form, and then x minus x2. This is the x-intercept format of a parabola. And we're going to go ahead and substitute x1 and x2. So this is our x1, -3, x2 is 1, and let's just substitute. So f of x is equal to, and we have a, and this is x minus, okay, -3, which becomes a +3 when you multiply in, and then x minus 1, which is -1. Okay, now you see at this point, you just have x's here, you have f of x. The only thing that is actually missing is the value of a. So that's what we have to find. How do we find a? We can find a if we had an x value and a y value. So you need one single point, which we actually do have, that y-intercept. So as a coordinate, this is 0 and 6. So just put that in. So we're going to substitute 0 and 6. And so this is your x, this is your y value. So this is 6 is equal to a multiplied by 0 plus 3, and then 0 minus 1. Okay, so that becomes 3, that becomes -1, and they multiply to become -3. So this is -3a is equal to 6. And then you can just divide both hand sides by -3. Therefore, a is equal to -2. Okay, so we found a, and now we can just put it back into this equation, which was almost complete. So this is f of x is equal to -2 multiplied by, and I'm just going to go ahead and start foiling out. So multiply, that gives you x squared. Then if you multiply there, you get -x, and then 3 times x is positive 3x. But together they will give you positive 2x, and then 3 times -1 is -3. Okay, then distribute in. So f of x is equal to multiply -2x squared minus 4x and plus 6. So there we go. We can see that therefore A is equal to -2, B is equal to -4, and C is equal to 6, and just like they said it would be. And that is our answer. Moving on to the next question. Question 5.3 says, calculate the coordinates of M, the turning point of H. Okay, so the turning point of our parabola. We can find that turning point because we have the full equation now in standard form, and we need to first find the x value. So the x value of the turning point is found by saying, so we can just start here, it's found by saying x is equal to -b over 2a. Okay, so see the value of b and a. So x is equal to, we already have all our values here. B is -4, so -4, and then all over 2 times a, which is -2. So that becomes a +4 over a -4, okay, because they multiply like that. And then it's going to give us -1. So x is equal to -1. So this is the x value of your turning point. So if this is the x value, how do you find the corresponding y value? Well, just take this x value and substitute it into the equation of h, and it will give you the y value that goes with that. So take the graph of f of x, the equation of f of x, and find its corresponding y value. So when x is equal to -1, what is the y value? So f of -1 equals -2 times -1 all squared minus 4 times -1 and then plus 6. F of -1 equals, and let's just see, this is going to be 6, that is +4. So together they give us 10. And then this gets squared and becomes +1 times -2 is -2. So that is 8. Okay, so there we go. The point M is actually just -1 and +8, and that is our answer. Moving on to the next question. Question 5.4 says, write down the range of H. So the range of H point now is -1 and +8. So the range refers to all the possible y values of this graph, all the y values that exist on this graph. This is a parabola, but it is a sad-face parabola, so it's concave down, meaning look at all the y values we have. We have a y value over here, so that's 8. And then you see how you have y values that are just less than this, okay, all through. These are all y values less than this. You can go to the points and see, okay, that's a y value there, that's a y value there. You'll notice that it will not have any y values up here, okay, for this parabola. And so the range would start from 8 and then all values that are less than 8. Okay, so we're simply just going to say the range of this is where y is simply all values greater than or equal to 8. Okay, if you wanted to write it in interval notation, you could just say y is an element of, and remember we're starting from 8 and we're going down to -infinity, okay? So thinking about it on a number line, if you say this is 8, we're saying values that are equal to 8 or less than 8. You're going to have to look at the smaller value here because it's heading to -infinity, okay? That would be the lesser value on the number line to the left, and then all the way to 8. And so here, infinity will get a round bracket, and then 8 will get a square bracket because 8 is an actual included y value here. So you could write it like that or like that, and it's fine. Okay, so that is our answer. Moving on to the next question. Question 5.5 says, determine the values of x for which h of x multiplied by p of x is less than 0. Okay, so when they say h of x and p of x, they're referring to the y values of these functions. So how do we get a value less than 0? Well, if h of x has values that are positive and you multiply it to p of x values which happen to be negative, we will get a negative value, which is a value that is less than 0. Also, if h of x happens to be negative and then we multiply it by p of x y values which are positive, it will give us a negative again, less than 0. So this is what we need to look for in our graph. Let's also speak about what it means for h of x to be positive, for example. So where is h of x positive? This is where it's greater than 0. So if you have the graph of h, which is a parabola, but even if it wasn't a parabola, it was just a straight line, where it is positive would be where it has positive, so h of x stands for y, so where it has positive y values. So this refers to the y values, so on the y-axis. Where does it have y values that are positive or greater than 0? That will be all through here. So if you're ever looking for y values that are positive, look for the places where the graph lies above the x-axis. Okay, so y values that are negative would be below the x-axis. Okay, let's go ahead and see what we have. So I'll pin this to the screen and let's check. Okay, so this is what we have, and we're looking for values of x for which h of x is positive, okay, where it lies above the x-axis, but then for the same x values, p of x needs to be negative. So where is h of x above the x-axis? That will be all through here. Now, for the same x values, and you can use a vertical line for this or your ruler. For the same x values, the graph of p should be negative. So let's see. Where does p of x have negative y values? So where is it below the x-axis for these parts that are highlighted? So if we start from here, we know that the graph of p is way above there. That's above the x-axis. So still not working all through here. There, it's still above the x-axis. They're both above the x-axis. So what we want to see is that h of x is above the x-axis, p of x is below the x-axis. But I'm not seeing that anywhere here. Okay, so all the way to this point, it's not happening. So this first scenario doesn't really happen, and that's fine. We can just let that go. Okay, now we're going to look for places where h of x is negative, so below the x-axis, but then for the same x values, p of x needs to be positive above the x-axis. Okay, so let's see. Where is h of x below the x-axis? That's here and here. Okay, now where h of x is below the x-axis, p of x needs to be above the x-axis. Does that happen within this region, okay, that we have highlighted? Okay, yes, it happens here because p is going to be extended all the way through there. And so it's above the x-axis all through here till this point. So we're going to take everything that exists here, okay, and tell them the values of x for which that exists. And then let's just see on this side where this is highlighted. You see over here how h is below the x-axis and p is above the x-axis. It also works here, but not all through, because look at what happens. See, this graph, okay, the graph of h, it's going to extend down, right? So it's still below the x-axis. And the graph of p is still above the x-axis. Okay, there I've highlighted the x-axis so you can just measure and just compare. So it's still above the x-axis, okay, and the graph of h is definitely below the x-axis because it shoots down. And then it gets to this point, and then that no longer happens. So what is happening here is it works, yes, but not all through. It works from this point, okay, it has to always be for the same x value. So from here and then all the way to this point, because this will extend down as well, just extends down. So they will both work until this point, up until that point. Okay, so now we can answer them in terms of x. So over here, what is highlighted, because we know that part is also going to be highlighted, but you know, we can't see it there anymore. But we're going to just say here, these are values that are, this is -3 over here, and it's values that are moving to the left-hand side of -3. So this is where x is less than -3. And then that's that answer. Over here, you see that it started working from 1, okay? And then it worked for all values that were clearly greater than 1, and then it stopped at 4, so less than 4. So this is where x is greater than 1, but less than 4. They didn't say anything about when you multiply them, they give you a value less than or equal to 0. They just said less than 0. So we're not going to even consider when they multiply and become zeros, okay? Okay, so these are our answers, and I'll just go ahead and put that down. So it means that x is simply less than -3, or x is greater than 1 but less than 4, and that is our answer. Okay, so like that. Moving on to the next question. Question 5.6 says, if h of x is equal to k, determine the value or values of k for which the roots are non-real. So this has to do with nature of roots, and we're looking at h of x. Yeah, I noticed I called this f of x the whole time, but it's the graph of h. It's h of x, not f of x. Now we're going to take the equation of h, and then we're going to just equate it to k like they said it's equal to. So take this, equate it to k. If you made h of x equal to k, you'd just be saying k is equal to, and then the whole equation of h of x. So they're referring to the roots. Where will the roots be non-real? Roots refer to x-intercepts. Okay, the way we find x-intercepts is by making y equal to 0. But in this case, you're not doing that. You're just equating this to k. And so to ensure that one hand side is equal to 0, so that you are finding the roots, you're going to have to transpose k. So this equation now says 0 equals negative 2x squared minus 4x plus 6, and the k comes over to become a minus k. This is the quadratic equation we have. Now, let's speak about the kind of roots that we can get. This refers to nature of roots, and it comes from your quadratic formula. So remember what the quadratic formula looks like. So this is the quadratic formula, and this part of the quadratic formula, we call that the discriminant, okay? So delta. It's going to tell you the type of roots that you will have because it's under a square root. If you square root a particular number, it will give you certain things. So for example, if you square root a number that is greater than 0, like 5, you just get root 5, okay? So this will provide you with real roots. But then if you square root a number that is negative, what happens? On your calculator, you'll get an error, but this is a non-real number, and so your roots will end up being non-real. So the only way we can get non-real roots is if that discriminant, okay, b squared minus 4ac, is a value that is negative, in other words, less than 0. So we're going to take this equation, let's find out what a, b, and c are, and we're going to ensure that delta is less than 0. Okay, so it is in the form of the standard form of a quadratic equation, which is ax squared plus bx plus c equals 0. So you can see the value of a is negative 2, b is negative 4, and c is 6 minus k. Okay, so let's substitute. B squared, that is negative 4 all squared, minus 4 times a, which is negative 2, and then times c, which is 6 minus k, and this is less than 0. And all we have to do is solve for this inequality. Okay, so negative 4 squared is 16, and then this multiplies to become positive 8, multiplied by 6 minus k is less than 0. And so 16, and then if you multiply, we get 8 times 6 is positive 48, and then multiply negative 8k is less than 0, and then add these together. So we're going to have, well, we can leave this here. It's fine, not a problem. And then 16 plus 48, that we can just remove a 4 from there. 20 plus 44 is 64. So you're going to take this positive 64 over, and so it becomes negative 64. Then we can divide both hand sides of this equation by negative 8. But remember what happens when you multiply or divide by a negative value? The sign will change. Okay, so divide both hand side. K is finally, now it's not less than anymore. It's now greater than. So K is greater than 64 divided by 8 is 8. And that is our answer. K is greater than 8. Moving on to the next question. Question 5.6.2 says we need to determine the values of k for which the roots have the same sign. So just the same sign. Okay. So that would mean they could both be positive or both negative. So something like x minus something, okay, and x minus something is equal to 0. Or it could be x plus a value and then x plus another value, a real value, and that is equal to 0. So it could be like that. Okay, so with this type of question, you see, it's not asking you for which your roots are going to be equal. Okay, they didn't necessarily say they will be equal. We must just have the same sign. That type of question, you can't really just use the discriminant like we did here to find this. This means you actually have to physically manipulate the graph. So you have to look at your graph. So let's take this graph and then just see how it can be manipulated so that that can happen. Okay, so here is our graph, and let's just see how we can manipulate it. The good thing about this is k is just a value that, it's just the value that is subtracted. So I need to just put that down. Just remember that, what that equation says. So let's just rewrite that. Okay, if this is equal to k, so then the equation ends up looking like that. Okay, so this is what the equation looks like. And we are going to take this graph, and I'm just going to keep in mind that that says negative k. So there's some thinking we need to do there at that point. So this is what we have. Okay, just imagine that it intersects like that. So we have this graph, and we need to think about how to move it so that the roots have the same sign. So right now, look at the roots. the roots have opposite signs. Okay, this is a negative root, it's a positive root. We want them to have the same sign. So let's see how we need to move them. So this intersects the y-axis here if I shifted it up, because remember as well, k, right? K is being subtracted to the entire equation of h, meaning it's either going to move the graph up or down. It's affecting this, which stands for h of x. So h of x stands for y, meaning you're either shifting this graph up or down because you are adding or subtracting to the y values of h. So you can take this graph and try to shift it up. What happens? If you shift it up, you see how this is not really going to help because it's shifting up, but it's always going to intersect. So it goes just wider and wider. It just keeps intersecting this y-axis here, and then it just keeps having opposite signs. So negative and positive. So up is not a good idea. Let's try moving it down. So there's also something I need to remember here because I'm like moving it down, but then, you know, we have a turning point here. That was -1 and 8. Okay, keep that in mind. So if you take this graph and you move it down, look at how it moves down. So I'm just moving it down. I'm not moving to the left or the right, or at least I'm trying not to. And do you see that it's going to move down to a point where the graph has its y-intercept at the origin? Okay. Then after this, if you move it further down, look at what happens. Look at the intercepts that you have. Look at the roots. That's a negative root. That's a negative root. That's a root of the same sign. So if you move it down, it works. If you keep moving it down, it keeps working until, of course, you know, it gets to this point. So it'll still have negative signs there, and then unfortunately just has one root. Well, in a way, I can't really just say, no, that's not an answer. I'll actually take that one as well. Because here, this is what it means for it to have one root, right? Let's say, yeah, we can already see where the root is going to be if it just moves from there and it moves to this point, right? If it moves from -1 and 8, so a y value of 8, and then it just moves down so that it touches the x-axis, that means its y value is now 0. So at this point here, this is where its x value is -1. Okay, I would also have to include that. The reason why is because if you're looking at the roots of a parabola with one intercept, this is what it looks like. It will end up looking like this. This is -1, right? The root is going to say x plus 1 times x plus 1 is equal to 0. That's what it will say. But ultimately, x is simply equal to -1. So in this case, this would also be the same sign. So I also have to include that scenario, okay, when it sits on the x-axis. Okay, so let's see. We know that that's the last place we want it to be, because if it goes any lower than this, you know, it's not going to have any roots. So leave it over here, and then let's see. Okay, so I duplicated this graph. So I just want to see how we must move it. So we move it down. You see that when we start having roots of the same signs, is when we move it to the point where it intersects, okay, with the origin, where its y-intercept is at the origin. So how far down must you move it for that to happen? Well, focus on the fact that this is a y-intercept. Where was the old y-intercept? It was at 6. So it means that you moved it from where it was intersecting the y-axis at 6 to where it intersects the y-axis at 0. You moved it how many units down? You moved it 6 units down. So with these ones with a negative there, I like to make sure that I actually write down the transformation first before thinking this part through. So move it down by 6 units, okay? So 6 units down. But then we're not just going to move it by 6 units down. It can be anything more than 6 units down. So not really just exactly 6 units down. If it's anything more than 6 units down, it has 2 roots of the same sign. See, both negative roots. And then if you keep moving it down, still both negative roots until it gets to this point. This is the last place where it has both negative roots technically, okay, or roots of the same sign. So, okay, we know how we need to move it. Move it down by 6 units, but no more than what? So look at this one. How far down must we have moved the original graph so that it gets to this one that we have? I think I should have just made them different colors. So this one, okay. How far down should we have moved that? We should have moved that exactly 8 units down. So it should go 6 units down, but no more than 8 units. And now we just need to write what that would mean for this negative k. Okay, so we are at an advantage here because this says negative k and we need to move the graph down. Okay, so we know it's already moving down. And so that means that if k is equal to anything less than 6, okay, not exactly equal to 6, unfortunately, because once you move it exactly 6 units down, it has a root 0 and then negative whatever that is. Okay, so k needs to be anything that is greater than 6, but nothing more than 8. Okay, so but less than or equal to 8. I have to include this equal to 8 because here these are also roots with the same signs, okay, technically, and that's what I was showing you here. Okay, so that would be the answer there. K is greater than 6 but less than or equal to 8, and that is our answer. Moving on to the next question. Question 5.7 says, calculate how graph P must be translated. So P, the straight line, must be translated so that it becomes a tangent to H. Okay. This question, if it was asked in grade 12, it would be so easy to answer because you can use rules in calculus, okay, to find this. But then in grade 11, you need to just think about it carefully and use the rules of grade 11 to actually answer this. So I don't want to start introducing any concept that will confuse you because then, it's not going to make sense. It's going to be grade 12 work really. So let's think about this. You see, we have the graph of H and we have the graph of P. What they're saying, and that's why I was copying this in the first place, but I thought I could use that. Let me just use this. Okay, so if this is what we have, what they're saying is tell us exactly how P should be moved. Okay, how should this be moved so that it becomes a tangent to this graph of F? So a tangent is a line that touches a curve at one point only. So they're asking how should this be moved? Clearly, if you move it up, it's never going to touch this parabola. So how should it be moved? Clearly down, but by how many units? Okay, if you shift it down and then there, okay, at this point where it touches the curve at one point, then it's a tangent. So that's what we need to figure out. We cannot use calculus here, but we can do this. Think about the logic behind this. They do not intersect right now. We want them to intersect. So what we could do is say, take h of x, and we're going to equate it with p of x. Then we are going to manipulate the discriminant and ensure that they intersect at one point only. The only way you can ensure they intersect at one point only is you equate them and you're saying that the equation they form must have only one root. And it's very similar to this. Well, not really similar to this, but I spoke about a concept here that actually touches on that. This x plus 1 and x plus 1. When you have a situation like this, right, it means that the discriminant, you see that b squared minus 4ac, it means that the discriminant was equal to 0. That's why you ended up with the exact same root. This is called equal roots, but it really just means that you have one intercept. Okay, so what we're going to do here is ensure that, so equate these, then ensure that delta is actually equal to 0, because that way it will only intersect once. Okay, so now we just have to apply this. So h of x, I keep forgetting what h of x was. Let me just get that. Okay, that was h of x. P of x was a straight line. We just used it once. That was, okay, 8 minus 2x. That's 8 minus 2x, and we're going to equate them. So it's equal to 8 minus 2x. And now you're going to equate them and just simplify. Okay, before equating them, because you're trying to find out how they need to be shifted, you could also see this as we're taking P and then we're shifting it down, then it reaches H. Okay, so in that way, what I would say for P of X is I'm going to say P of X and I'm going to have to say plus K or plus some sort of variable so that I'm saying I need to find the value of K for which this will happen. Okay, how should this graph be shifted so that they intersect at one point? In other words, the graph of P is now a tangent to the graph of H. Okay, so I'm going to go with the P of X plus K. So add a K here and then figure out what exactly K should be, and that will tell us the translation. Okay, so this is what we have, and let's just simplify this. Okay, negative 2x squared minus 4x, bring that over to become positive 2x, and so it gives us negative 2x. And then we have positive 6 here minus 8 would give us negative 2, and then just bring k over. So it's minus k is equal to 0. So we need to ensure that the discriminant is equal to 0. So b squared minus 4ac is your discriminant. We need to ensure that it's equal to 0. So what's the value of a? Okay, you can see the value of a is negative 2. The value of b, that's the coefficient of x. What is multiplying to x? That is the negative 2. And then what is c? That is whatever is not with x. So that is c. So this is b squared negative 2 all squared minus 4 times a, which is negative 2. And then times c, which is negative 2 minus k. This must be equal to 0. And so we need to find the value of k for which this is true. Okay, so that gives us 4. We multiply and get positive 8. And then this is negative 2 minus k equals 0. Then 4 and multiply in. That's negative 16. That's negative 8k equals 0. Okay, so this is still negative 8k. And then if you add, say 4 minus, or subtract, 4 minus 16 is negative 12. But if you transpose negative 12, it gives you positive 12. Then divide both hand sides by negative 8. Therefore, k is equal to, they are both divisible by 4. So it's negative, but then 12 divided by 4 is 3. 8 divided by 4 is 2. Okay, so it's k is equal to negative 3 over 2. So remember where k was applied? To p of x. So I'm saying for this to happen, because they didn't just say find the value of k, I introduced k here so that we can just work with a variable and see what happens. But we applied it to p of x, right? And it's a negative. So the question is, you need to calculate how the graph of p must be translated so that it becomes a tangent. So how should it be translated if this is now p of x minus 3 over 2, because this said plus k. Okay, so add k to this, it's plus negative 3 over 2, which is minus 3 over 2. This really just means you take the graph of p of x and you subtract 3 over 2. P of x stands for the y values of p. If you take all the y values, it means you are taking that graph and you are shifting it down. Okay, you know that that graph looks like that. You're taking it down by 3 over 2 units. And that's what we are doing there. Okay, so how far must it move down? It must move down by 3 over 2 units. So you can just say that in words. Okay, there we go. P must be shifted down by 3 over 2 units. So yeah, I see that you can't really use the graph of H. They gave you instructions to use P and tell them how P should be translated. So you have to actually use P. So P must simply be shifted down by 3 over 2 units. These are the two keywords they would look for there. And that is our answer. And that is it for question 5. Okay, so that is it for this paper. That's the last question. I hope you guys enjoyed it and I hope to see you guys in paper 2.